Okay, this is lesson number 4, simplifying radicals, specifically numerical radicals. On Monday, we're going to simplify radicals with variables or algebraic radicals. But today we're talking about numerical radicals. Okay, and radicals again are those square root signs that we're used to seeing, like square root of 4. I talked about yesterday. Okay, we know that the square root of 4 is 2, right? It's also negative 2 because we're looking for two numbers that are multiplied with themselves twice to equal the number on the inside. Okay, and the way I teach my students this how to deal with radicals is you look at the index. In this instance, the index is 2, and we have to ask ourselves what time. We know that 2 times 2 is equal to 4, or negative 2 times negative 2 is equal to 4. Okay, and since the number is 2 on the outside, let me tell you a story on how I teach my students. So the radical sign is like a prison for numbers, okay? And you want to break out of the prison. But the only way you can break out of the prison is you look at the number on the outside. This is the index. This is how many people of the same kind you need to break out of the prison. So one night, a couple of 2s try to break out of prison. They're like, hey, we could break out of here. We just need a pair of us. So they hold hands and they run out the door. And they're like, we made it! But the guard shot one of them and killed him. And the other guy made it out alive. So there's no one left in the prison, so the prison disappears. That's the answer. Or in this other prison, these 2 negative guys are like, I hate this place because they're negative, right? So try to break out. And so one of them says something mean to the guards, bam, gets shot. Only one makes it. Okay, that's the way I look at it. All right. Anyways, that's how you do a simple way of doing that. Okay, so that's what we're looking at. Here are the steps. So identify the radicand and index, very important. 2, factor the radicand and identify any roots. And 3, simplify. Okay, so here we go. I'm going to do numbers 1 and 2. Pencils down right now. Eyeballs on the screen. Okay, pencils down. Pencils down. You'll get a chance to write, I promise. Okay, here we go. So, number 1, square root of 36. First thing I'm going to do is figure out what is my index and radicand. So, there is no index here. What can I assume is there, everyone? 2, right? So, we assume it's 2. I'm going to just leave it alone and not put anything there because it's assumed. So, we know that 36 is our radicand. So, the first thing I want to do is factor out 36. So, 36 could be factored out as positive 6 and positive 6. It could also be factored out as negative 6 and negative 6. Okay, so if that's the case, then I would rewrite my square root sign a couple different ways. Times negative 6. Bless you. Okay? Just like the story before, we know the index is 2, so you'd have to break out in pairs. So these 2 6s try to break out. Only one makes it. The other one doesn't make it. So you got 6 makes it out alive. So and then there's no one else left inside, so the radical sign disappears. Or these 2 negative 6s try to make it out. One of them doesn't make it. The other one does. So negative 6 is an answer. That's number 1. Okay. So what did I just do? The first thing I did again is I identified the radicand and index. Radicand is 36. Index is 2. That's assumed. Second thing is I factored the radicand and identified any roots. So these roots are I factored out 36. I know the square root is 6, so I rewrote it, and then I used the prison method. That's just the story I use because it is helpful when we have bigger indexes. Okay, and that's it. So that's number 1. Number 2, square root of 80. Watch carefully. Square root of 80. Is 80 a perfect square? No. Okay, but I know that 80 is can be factored out. Okay, so looking at 80, we know that the index is 2 in this one, so we have to find pairs. Okay, so 80 is just like saying 16 times 5, okay? 5 is prime, so I'm going to circle 5, okay? I can't factor out 5 anymore. But 16 is like saying 4 times 4, and I know in the back of my head I need pairs of 2, right? So 4 and 4 would work, okay? So I'm going to rewrite this problem with 80 being factored out as 4 times 4 times 5, okay? Now in this example, the index is still 2. So, a couple of 4s pair up, they hold hands, they try to make it outside. One of them gets shot, the other one makes it outside. This 5 is a loner. Does he make it outside? No. Poor guy. He's still stuck in prison. 4 rad 5. Okay? That's it. Yes, questions?
In all cases, is there always going to be the last number to stay in there?
Yeah, if there's a number that stays in there, then it stays in there. Sometimes there's 2 numbers that stay in there because there's 2 loners, or there's not enough people to get in there, or to break out, so then you would multiply those numbers inside, simplify.
Okay.
And we're going to look at that, okay? Okay, so I'd like you to do 2s today. We're starting with talking about number 1. Yes, question?
We have used 8 and 10.
Yeah, you can use any number. You can use 8 and 10. It's a good question. So 80, one more thing. You could factor whatever order you want. You'll still get the right answer. So we know 80 and 10 is 8 times 10. And we know 8 is 2 times 4. And then 2 is primes. And 4 is... Oh, excuse-moi. 4 is... I'm sorry. 2 times 2. These are both prime. And then we know 10 is 2 times 5. Right? So this one's a little bit a longer way to do it. These are all prime, right? So we know that 80 could also have been written like so. That's a really good question. Is 2 times 2 times 2 times 2 times 5, right? All of this is a square root, right? They need to break out in what? What number? Index? What's the index? 2. So they could break out in 2. So these 2 guys pair up. These 2 guys pair up. What happens to the 5? He stays inside. He's a loner, right? So these other guys try to make it out. Only one of them makes it from each pair because, you know, there's the guards get them every time. There's no way they could get out. So on the outside, only 2 2s make it, and one of the 5 stays, or the 5 stays inside. 2 times 2, 4. 4 rad 5. So yeah, you could go any order. That's a great question. Thank you for asking that. Okay, anyways, 2s are talking to the 1s about number 1, 2, and 1's talking to the 2s about number 2. Ready, set, talk. Okay, number 3, we got rad 32. Rad 32. So, let's do this one together. Turn to your neighbor, tell them what's the index of number 3. 2. Okay, good. What's the radicand? Okay, 32. So the first thing you want to do, we're doing this one together. So 32, let's make a factor tree. Oh, apologize. Factor tree. Okay, 32. What times what is 32?
8 times 4.
8 times 4. Okay, that's good. Let's think of perfect squares too.
16 times 2.
16 times 2 works also. Good. Okay, so 16 times 2, we know 2 is prime. And 16, right, we're looking for pairs. Isn't 16 a perfect square?
Yeah, 4 and 4.
4 and 4, right? So let's just stop right there because we know we need a perfect in order to complete a problem. So we got the radical sign is really like saying 4 times 4 times 2. Okay? They need to break out in pairs. So let's see it on your whiteboards. Give you about 15 seconds. Go. So, number 4 was 4 rad 2, or 3 was 4 rad 2. Okay, on this, look up here, 4 rad 2. There's actually, I want to show you something. This 4 is a coefficient, okay? It's not the index. What's the index still? 2, okay? So between the 4 and the rad 2, there's actually an imaginary multiply sign. You all know that, right?
No.
If you didn't, there's an imaginary multiply sign, okay? We don't put it in there because it's just redundant in math, so we don't put it there. So it's like saying 4 times rad 2. You following me? Okay? So that's the answer. I want to let you know that because that's really important. Number 4, go. The correct answer on this one is 8 rad 2. How did I get that? Okay, 128. Whenever you have an even number and you don't know how to break it down, what can you always start with an even number? 2. So you ask yourself 2 times what? It's 2 times 64. If you didn't know it, you just do a side problem. And then we know 64 is a perfect square of 8 times 8. What's our index on this one? It's a 2, so we know that we could break out we need to have them break out in pairs, okay? So these come out, boom, one gets taken out, so we got 8 rad 2, okay? Going quickly here. Make sense? Good, next one. Now, number 3 is a little harder. Okay, number 3 is harder. Now, what's different about number 3? Raise your hand and when you see the difference from number 3 and number 2. Raise your... Uh-huh. Where is there a 3? Good. Did I just say the answer in my question? I think so. Okay, good. So the index is 3. What does that mean now for our prison?
You need three numbers.
You need 3 numbers to break out. So let's do this one together. 256. I know it's scary. Don't worry though. 256. 256 is what times what? 16 times 16. Okay. Can we break out? Can the 16s break out?
No.
Yes.
Can the 16s break out?
Yeah.
Oh, yeah.
No, they can't.
Can the 16s break out?
Oh.
No.
Good. No, they can't.
So why are you not?
Hey, buddy.
Because he's messing with you. You need 3 twos, man. That's
You need 3. You need triplets, right?
yes, 3
That makes a lot of sense.
Oh.
Okay, so since 16 can't break down, we have to, or can't be taken out, we have to break down each of these 16. So 16 is, we know is 4 times 4 on each of these, right? So we have 4 4s, okay? We only need at least 3, so check this out. Now we take 4 4s, put them inside. We just factored it out. We know it's a cube root, so make sure the 3 stays on the index, okay? Since there's a 3 on the prison walls on the index, they need to break out in groups of 3. So 3 4s, they group up, they're holding hands, running out the doors. We're going to make it. We're going to make it. And since this prison is a 3 on the index, there's more guards. So 2 of them don't make it out. There's only 1 that always makes it out. Okay? And there's only 1, not 2. So 1 of the 4s makes it out. Okay, this last 4 that stayed on the inside, oh, poor 4. Didn't make it. It didn't get shot, that's right. So the answer here is 4 rad 4. Did you get it? Nice. Yes.
So like for the index, no matter what number it is, there's only one that comes out. Always.
Always, yeah. Good question. So the index could be 7. On your homework, there's be an index with 7. That means you need 7 of the same number to break out. 6 of them will get taken out by the guards, and only 1 will make it. Does that make sense?
Still leaving 1 inside though. That's not in the group.
If there's someone not in the group, or there's a lot of people not in the group, let's say you need 7, but you only have 6 of one number, then those 6 won't make it out.
If there's like
You need 7 of the same number.
if there's like a 4 and a 2 and the radical sign, you just time those.
You would times those, multiply them. Yep. Okay, number 6 is the last one. So this one's a little hard too. So let's start this one off together. What's the number on the inside? 625. Okay. Let's start with just that, and it's negative, right? So, but let's just ignore the negative sign right now. I want to give you a hint on how to deal with this. 625 is like what times what? Who said that? Yes, you go, girl. Okay, so 25 times 25, right? What is the index?
It's 3.
It's 3, so can these 25s make it out?
No.
No, they can't. Okay? So, we have to break these 25s down again. So, we know that 25 is 5 times 5, right? Okay? So, just like the last problem, we still have a negative sign, but this 625 is really like saying 5 times 5 times 5 times 5. Okay, what's the coefficient on the outside of these 5s? No, the coefficient, not the index. 1. So it's really like saying negative 1. Would y'all agree? Okay, so we're going to factor out a negative sign. Let's think about it. Negative 1 is just like saying negative 1 times negative 1 times negative 1. Would y'all agree with me?
Yeah.
Yeah, because if we had 2, it's negative 1 times negative 1 is positive. So we know that could work. So since these 3 negative 1s can make it out, we could factor out a negative 1, right? Right? So these 3 5s try to make it out. They pair up. The 5s make it out. This negative 1 makes it out. But this last 5 doesn't make it out. And since we have a negative and a 5, we have negative 5. Now another way you could have done this. Another way you could have done this is as follows. Isn't 625 negative 625 like saying negative 5 times negative 5 times negative 5 times positive 5? Would you all agree with me? Negative times negative is positive, times negative again is negative. So we want to end off with a negative, so we're going to multiply the last 5 with positive 5. You got me? So we got 3 negative 5s that could have made it out too. I'm trying to show you 2 ways to do it. This one's confusing.
So negative 1's easier.
I don't even use negative 1. In my head, I just think negative sign. Negative times negative is positive, times negative is negative, right? So I need 3 negative signs to break out. Does that make sense? So whatever way you want to look at it, but be careful with the sign. It does make a difference on this one. Does it make sense? Okay, and that's it. So that concludes this lesson.